Hello. Um, I'm Jimmy, and I have my screen over here, but I'm just going to do the Calc BC 2025 exam as fast as I can to try to see like how long it takes. I don't actually remember how long it takes. I don't actually remember much about Calc 2, but I'm gonna try to do it and get it all right. And if I don't get anything right, I'll correct my work at the end. But that's basically it. I'm gonna set a timer, see if I can do it really fast. I have a cherry coke, and that's about it. And I'll also include like snipping, like copying over the exam stuff onto my page too. So let's start the splits. And I'm not going to explain anything either. I'm just going to kind of do and then record this. So fun. Okay. Let's pull up the exam here, have it here, and I'm just going to like take a snapshot of it. And I'm just going to paste it into this. Yay. And then I'm going to take a picture of the first question also. Copy this. This first section has a calculator, so I'm just gonna like plug it into my calculator. I even put you should have your calculator in reading mode. That's kind of weak sauce, to be honest. Oh, I have a calculator here too, so that'll be fine. Let me sure I'm in radian mode actually. I'm in radian mode. Okay. Um, C of t represents the number of acres in a fruit grove. We have C prime of t. Find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. So average number is going to be like an integral thing. It's going to be, oh, low battery. Average is going to be like 1 over b minus a, integral from a to b of c of t dt. So that's going to be c average is equal to 1 over b minus a. So from 4 minus 0, integral from 0 to 4 of c of t, 7.6 arctan 0.2 t dt, which is approximately, if I plug in my calculator, 1/4 finite integral from 0 to 4 of 7.6 arctan 0.2 x dx, which is 2.778. That's question one. Question two is, I think it's Windows Shift S or something. I'm not certain. This one is find the time when the instantaneous rate of change of c equals the average rate of change of c. This is an interesting question, I guess. So we want instantaneous rate of change of c, so c prime of t is equal to the average rate of change over the time interval. So that's going to be c of 4 minus c of 0 over 4 minus 0, right? So it's the slope. It's like for some arbitrary function, ct, we're going to have c of 4, c of 0. The curve might actually look something like this. Average rate of change is this slope, and we're just getting the instantaneous slope at some point, time t. Try to find some point where like maybe like what would I be looking for? Like a point. This is something more like this. Maybe like this point we're looking for when the slopes are the same. And this is like this has to exist due to like Rolle's theorem or something. Okay, so c prime of t is 38 over 25 plus t squared. That's going to equal to c of 4, which is 7.6 arctan. I'll write tan minus 1, save space, 0.8 minus 7.6 arctan 0 over 4. Solving some of this out, at least the right side, 7.6 arctan 0.8 minus 7.6 arctan of 0, which I think is, I have no idea. That is 1.1 1.28200, whatever, equals 38 over 25 plus t squared. We can graph both these and get the intersection line. We also probably just solve it out. This becomes 38 is equal to 25 times 1.282, 32.05 plus 1.282 t squared. Move that over, 38 minus 32.05, 5.95 is equal to 1.282 t squared divided by 1.282, and then square root it, take the positive answer because we're doing it with time. It's going to give us t is equal to 2.154. And that is going to have a unit. Oh, this should also have a unit. This should be acres. This down here is time, and t is measured in weeks. So this is weeks. Cool. Next question. Is it Windows Shift S? It is Windows Shift S. I'm so amazing. Okay. Okay. That it saves it somewhere else on my computer. That's so annoying. I just want snipping tool, man. I want to copy it easily. It's annoying. Okay, next question. Uh, Next question. Assume that an invasive species continue to spread according to the given model for all times t equals greater than 0. Write a limit expression that describes the end behavior of this rate of change, the number of acres affected by the species. This is going to be the limit as t approaches infinity of c of t, which is the same thing as the limit as t approaches infinity of 7.6 arctan 0.2. 7.6 arctan 0.2 t. You can like look at tan to like see, or you can kind of imagine tan. So like inverse tan is we're taking a ratio of y over x, so some slope on like the unit circle as it approaches as the slope approaches infinity, right? So that only happens when like imagine if this is a ray for the unit circle at some angle theta. And normally tan of theta is going to give us this slope, right? This m. When this m approaches infinity, well, this is flipping, right? So theta, we're getting the angle theta from some tan inverse of our slope. So the only time our slope is infinity is when the side's perfectly vertical. And that happens when theta is pi over 2. So this should be pi over 2, 7.6 pi over 2, or 7.6 times pi over 2, which is equal to 11.938 acres. We want a limit expression which describes the end behavior of the rate of change of the number of acres, actually. So we don't actually care about the number of acres that will be affected. We care about the rate of change. That's limit as t approaches infinity of 38 over 25 plus t squared. We can divide everything by t squared to get the limit as t approaches infinity of 38 over t squared over 25 over t squared plus 1. That goes to 0. This goes to 0. We get 0 over 1. Or, I guess, sorry, this should be an arrow. Or, yes, or yeah, this should goes to this equals 0. So as the number of acres, the end behavior in the rate of the rate of change is gonna approach 0. Um, yeah. Next question. Final question. This is an interesting question. At time t equals 4 weeks. Oh, I don't know if you could see that or not. I was paying attention actually. You probably couldn't see this writing I was doing up here, but I was doing something. Time t equals 4 weeks. At the invasive species appears in the fruit grove. Take account of the spread of the species, so we're changing our function. At what time t for between that is a attain its maximum value. So we maximize a of t when or we maximize a of t when a prime of t equals 0, right? Following the what it was like if this was A and this is, or we want to maximize A, yeah. So A and T, so whatever curve, the maximum, always the slope is going to be 0, right? Over some interval. So that means we also need to include the bounds of the interval. So we need to check 4 and we need to check 36, as well as checking for any local maximas. So to evaluate A prime of t is going to equal C prime of t minus the integral, or this, which by the second definition of derivatives is just equal to 0.1 times ln of t. Then we can evaluate everything. So we start by saying, okay, let's find local minimum maximums. This is equal to 0. When C prime of t is equal to 0.1 ln of t. C prime of t before was C prime of t was 38 over 25 plus t squared. And this is definitely one that's not going to be solvable. So I'm just going to plug it into my calculator. First function is 38 over 25 plus x squared. Next function is 0.1 ln x. And I'm going to set my window size to be between 4 and 36. And of course, it has to be that. I don't know what numbers we're thinking about. Probably some simple numbers. I'll start with 0. Now I'll do like -10 to like 20. And then I'll graph that. Let's see, graphing two functions. Looks kind of tiny. I'm going to reduce my window size by a bit. So I'm going to go to like 5 to 5, I think. -5 to +5. And graph that again. That looks a little better. Which one the intersection looks like they have one intersection point. I'm going to calc intersect between two curves. Move my little pointer over. Move my other little pointer over. So I find there's one intersect at t equals 11.4417. And then what we do is we evaluate a of 4, which is equal to c prime of 4, 38 over 25 plus 4 squared minus 0.1 ln 4, which is equal to, I guess it wants at what time, right? So we just pick whichever one has we pick the t value for the largest value we get when we plug this all in. So 0.1 ln 4, this is equal to 0.788199. Then we do a of 11.4417. So you plug in 11.4417, which I could have done a little better if I did x from the start, but I didn't. X squared minus 0.1 ln x. This is 0. Basically 0. Then we do a of 36. Eating right now? What do you want? Thank you for the mail. Oh, I'm plugging the wrong function, by the way. I'm plugging into the derivative. I'm plugging into a. So a is this function c of t. So a of t should be let's see. C of t 7.6 arctan 0.2. 0.2 and then minus integral from 4 to t 0.1 ln x dx. If I get 4, 4 is going to be, or this should be 0.2t, so you plug in 4, so we get 7.6 arctan 0.2x minus the integral. So the finite integral from 4 to x of 0.1, I use a different letter like b, or 0.1 ln b db. This is 7.317. The next, oh wait, sorry, that was for a equals this. 7.317. We plug in 4 into this. We get 5.218. Plug in 36. We get 1.74. So A attains its maximum value at t equals 11.417. First question in about 14 minutes. Next question. We have some Oh, I hate polar curves. I'm probably gonna get this one wrong. Uh, da 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 da. This is the question. We have some curve. Yay, polar coordinates are so fun. Find the rate of change of r with respect to theta on the point where that is that. Okay, so this is just find the derivative. Find the rate of change of r with theta on the point where curve C where theta equals 1.3. So some angle looks something like this. This point here, wait, this is r as a function of like theta as per this angle theta. So this is curve C, and then, or this is curve C, and then this is the semicircle there. So we do this. Derivative is just going to be r prime of theta, which is equal to, did I take the derivative of that? It's going to be 4 sine theta times the derivative of sine theta, which is cosine theta, which is also equal to 2 sine 2 theta. Um, Find the ratios of r with theta on the point of the curve where theta equals 1.3, equal to 2 sine of 2.6, which is just equal to 2 sine 2.6, 1.031. Cool. Next question, part B. Find the area of the region that lies inside curve C but outside the graph of the polar equation. So we want inside curve C but outside the polar equation. So we want this region here. So first we need to find these two bounding angles, this one and this one. So we need to set our curve C equal to the curve 1/2. So that's just going to be setting 2 sine squared theta is equal to 1/2. So we get that sine squared theta is equal to 1/4. Sine theta is equal to 1/2. Um, I don't remember which primordial angle this is. 0.5235. Is that like pi over 2? No. I don't remember, to be honest. Oh, it'd be pi over 3, pi over 4, pi over 2. I don't know what I'm trying here. Okay. I get theta equals from the arc sine, I get 0.524 or 52, sorry, 36. Sure. Then the other solution is going to be so if we have some angle of 0.52, where pi over 2 happens to be pi over 2 is 1.57. So if this vertical line represents a ray of 1.57, our answer is 0.5, so probably somewhere around here. So this y value represents our answer. We have an equivalent answer over here at this y value. We can also kind of tell this because it's graphed between 0 and pi. So, and have to be two solutions, so it's going to be this one and this solution. Meaning we could find this solution by taking pi minus our other angle theta. So this is theta 1. Theta 2 is going to be pi minus theta 1. Or theta 2 is pi minus theta 1. So pi minus 0.5236 is 2.618. And I'm rounding to when I think it's nice. Finally, to find the area between the two regions, we want the area between two polar regions. How do you do this with, I don't quite remember how to do this not in a Calc 3 way. I might just do it in a Calc 3 way. Do I want to do it in a Calc 3 way? Let me think for a sec. Okay. Here's what I'm gonna do. Uh, let's think of the area of a polar region. Um, S is equal to R theta, so ds is equal to R d theta. Um, okay, so let's say wait, what about area? Area is equal to 1/2 theta r squared, right? So d area is equal to theta r dr. No, wait. 1/2 r d theta. Something comes down though, doesn't it? Uh, um, um, um. There's a formula for this, you know. I think there's a 1/2 that goes here or something. I think it's 1/2 r squared d theta. That seems about right, man. I don't remember very much. So our region area is going to equal the integral from our two bounds, right? So 0.5236 to 2.618 of the outer function, which is r of theta. So 2 sine squared theta squared minus, so that's the outer area. Oh, and there's a 1/2 out here too. That's the outer radius minus the inner radius, which is 1/2. So minus 1/2 squared d theta. So that would be our integral there. I think that's right. We'll have to check with the answer. I'll check the answer at the end. Inside C, but outside 1/2. Okay. Next question. Um, question C. It could be shown the dx d theta is equal to this. Find the value of theta that corresponds to the point on the curve C that is furthest from the y-axis. Justify your answer. So dx d theta represents the change in x value, right? The change in x value as we get away, or as our angle theta changes. So we sort of think of theta as some arbitrary parameter that describes a point on our curve C that has some rate of change away from along the x-axis, which is away from the y-axis. So we're going to look for when this rate of change is maximized. Rate of change is maximized at 2 points here, not here, here and here, right? So when this rate of change is maximized, so you say like dx. I don't really want to explain it. I'm just going to write the answer. So we're going to want dx d theta is equal to 0, basically. So we want where this, so theta is some arbitrary parameter that describes a point on this curve. We want x, we want the change in our x to be 0, which represents like the furthest point away from it, because the maximum of any function is when its derivative is equal to 0. If we have x as a function of theta, we want to maximize the function x as a function of theta, so we want the derivative to be 0. So we want this to equal to 0. We want 4 sine theta cosine squared theta to equal 2 sine to the third theta. This can go, this can become to the second power. We're losing a solution, whatever. 2 cosine squared theta is equal to sine squared theta. We can write this as 2, 1 minus sine squared theta is equal to sine squared theta. Distribute this 2 out. 2 minus 2 sine squared theta is equal to sine squared theta. Move this over. 2 is equal to 3 sine squared theta. 2 over 3 is equal to sine squared theta. Sine theta is equal to square root of 2 over square root of 3. Theta is equal to, we can arc cosine, or we can arc sine this answer, so square root of 2 over 3. I put a plus sign by accident. 0.95531. If we divide that by pi, it's like 0.3 pi. So if we imagine like, so pi over 4 is 0.25 pi. It's going to be, so pi over 4 would be like a line that looks like this. We want a little more. So this is 0.25 pi angle. We want like 0.3 pi. So that seems about right. This what we got was like 0.3 pi, which seems about right for this answer, I'm assuming. Hopefully that's right. I think that's pretty good. I don't know if they want, because like there's two answers to this question. I don't know which one they want. So that will say it's fine. Next up, one question. A particle travels along curve C so that d theta as a function of time is equal to a constant. Find the rate at which the particle is distant from the origin with respect to time. Right. Find the rate at which the particle is distant from the origin changes with respect to time when the particle is at the point where theta equals 1.3. The particle's distance from the origin changes with respect to time. Distance from the origin. So distance from the origin is going to just be r of theta, right? Find the rate at which the particle's distance from the origin changes with respect to time when the particle is at the point. Okay, so this is a chain rule problem. So we can find r. So when we find r prime of theta, this is equal to dr d theta, right? Multiply that by then, but theta. Let's say theta is a function of time. To get r as a function of time, we then need to multiply. So we want r as a function of time. We then need to multiply by the derivative of theta, which is the derivative of theta with respect to time. The theta will cancel out. We end up with dr dt. So we want dr d theta, which I think we solved for earlier. Dr d theta was 2 sine 2 theta. It's going to be 30 sine. Oh, wait, hold on a sec. Yeah. So we're going to get 30 sine 2 theta, plug in 1.3. So this end up being 15 times 2 sine 2.6, which we found earlier. 2 sine 2.6 was 1.031. So it's going to be 15 times 1.031, which is the 15.465. Next question. No more calculator. Oh, and this section had a time limit of 30 minutes. We took 26 minutes. Pretty good. Next part. Part B, we have 1 hour. The next section. Okay. So 26, we should be done in about 1 hour 26. Depends how long this takes, though. All right. So here such reading at time equals 0. Your next 10 minutes. The rate at which he reads is modeled by a differential function r. We have values of r of t. Cool. Approximate r prime of 1. This we just pick the two best points and we find the slope between them. This is going to be r prime of 1 is equal to r of 2 minus r of 0 over 2, which is equal to 100 minus 90 over 2 is equal to 5. And the derivative is going to be words per minute squared. Because r is in words per minute, derivative that is going to be words per minute, which is that. Cool. Next question. These are going to be way easier because I don't have to use a freaking calculator. Let's see. Must there be a value such that r of c is equal to 155? Oh, made that really big, huh? Let's see. So between 0 and 10, we go from 90 to 150 to 162. So yes, that's true. Yes, since r of c is different, or since r of t is differentiable, it is continuous. Is it intermediate value theorem that says, I don't remember which theorem specifically it says it, but US. Since r of 8 equals 150 and r of 10 equals 162, the curve must pass through all a in the set of real integers such that a is between 150 and 162. Must pass through all a in the real numbers such that they're between that. So there exists a C, and I want to specify that it's between 0, between 8, between that, and then between 10. So I kind of represent that. We got a more specific answer than they wanted, but it's fine. Such that R of C equals 155. Sure, that looks good enough. Okay. Use a trapezoidal sum with 3 subintervals indicated by the data to lead to this answer. Okay, I don't quite remember how this works. So I think we have like point to point, make a trapezoid of the area, right? So it's going to be base 1, base 2, height. So I think area of a trapezoid is base 1 plus base 2 divided by 2 times height. Sounds about right. The average base times the height, right? So this integral 0 to 10 of r of t dt is going to be equal to first set of data, which is r of 0 plus r of 2 divided by 2 times 2 plus r of 8 plus r of 2 divided by 2 times 6 plus r of 10 divided plus r of 8 divided by 2 times 2. And they can plug in numbers. R of 0, or r of 0 is 90 plus 100 over 2 times 2 plus r of 8, 150. 150 plus 100 over 2 times 6 plus 162 plus 150. 2 times 2. This then becomes 190 plus 250 times 3, which is 750, right? Because that leaves over behind a 3, 250 times 3, 25 times 3 is 75. And then we end up with plus 312. Okay. 750 plus 190, 14, 8, 9, 940. 940 plus 312 is 2, 5, 1, 2. 1, 2, 5, 2. And the integral, this is going to be words. So words. Boom. Next question. What the? Why are we highlighting things? Stop that. A teacher also starts reading at some time. Oh, what? Why would I ever want to? Why would I ever want to share this to anyone? Why would I ever want to? Why would I ever want to? Why would I ever want to share this to anyone ever? Um. Okay. Function W. Word. W's measured in words per minute. Cool. How many words has the teacher read by the end of 10 minutes? W is teacher reads is modeled by the function W, measured in words per minute. How many words the teacher read by the end of 10 minutes? Is this just asking me to take the integral? Okay. Let's take the integral from, I think this is just integral from 0 to 10 of W of t dt. She starts, she starts reading, so the initial value is 0. It's going to be 0 plus, I guess it should be like initial value. Let's say there's some function R of, so like let's say we're trying to figure out R of t, which is the number of books read at some time t. That's going to equal R of 0, which is 0, plus the integral from 0 to 10 of W of t dt, which is the same thing as R prime of t. So it's going to equal 0 plus the integral from 0 to 10, negative 3 over 10 t squared, plus 8t plus 100 dt, which is equal to, add 1 divided by the power, negative 1/10 t cubed, plus, divide by the power, so that's divided by 2, so this becomes 4t squared plus 100t, evaluated from 0 to 10, plug in a 10 basically, we end up with negative 1000 over 10 plus 4 times 100 plus 100 times 10, which is equal to negative 100 plus 400 plus 1000. which is equal to 1300. And that's going to be words. Fun. Next question. Question 4, where we have this continuous function, which is cool. I like cool shapes, which never appear in the real world, but we learn about them. And the next question is for A here, which is just find g prime of 8, give a reason for your answer. Our function g is, so this is f of t. Function g is going to be this. So since this is an awesome function, we use that second rule of calculus, which says when we function like this, g prime of x is just going to equal plug x to the function, so f of x. So g prime of 8 is equal to f of 8. F of 8 is 1. Cool. Next question. Find all values of x in the open interval this, so not including the edges, that has a point of inflection. For g has a point of inflection, so we want to find g double prime here, which is of x, which is equal to f prime of x, which is equal to 0. So we want all times when f prime of x equals 0, which is going to be here, here, and not here, because there's no thing there. So we x equals -3, and x equals +3. I think also a point of inflection has to switch from positive to negative accelerate. No, it needs to have a constant acceleration. It needs to switch derivatives. So we'd also want to see that g prime of x switches from positive to negative. So that's equal to f, just f of x by itself. So we see that, or hold on a sec. Double prime, I think I'm mistaken actually. The point of inflection is something that looks kind of like this, right? So the acceleration equals 0. I guess the acceleration switch signs, right? We can see here that the acceleration, which is the second derivative, which is the slope of this line, switches from negative to positive here, switches from negative to, or switches from positive to negative here. So I think those are good points then. Yeah, let's pick these two. Next section, part C. Find g of 12 and g of 0, label your answers. This is going to be that question where they ask us to do, what's it called? Just summing stuff. So g of x is equal g of x is equal to the integral from 6 to x of f of x dt, or f of x d, or f of t dt, sorry. Doesn't really matter what variable we put there. Right? So g of 12 is just equal to 6 to 12 f of t dt. This is just going to be the area from between 6 and 12. So 6 to 12, which is going to be this half triangle, which is 1, 2, 3, 4, 5, 6 units across, 3 units tall. So it's going to be equal to 6 times 3 over 2, which is 18 over 2, which is 9. For the other one, the g of 0, that's going to be equal to the integral from 6 to 0 of f of t dt. Since this is flipped around, we can use the integral like reversal rule to just swap it, right? I should actually fix this camera a little. There we go. So we can take that is equal to the negative sign of the integral from 0 to 6 of f of t dt. So we just want the positive area from 0 to 6. So the positive area from 0 to 6 is just going to be the size of the semicircle, which has a radius of 1, 2, 3. Yep, just a semicircle of radius 3. So it's going to be pi r squared divided by 2, because it's a semicircle. So you put a negative pi 3 squared over 2, which we could say is just negative 9 pi over 2. Finally, next question. Find the value of x at which g obtains an absolute minimum on this interval. Same thing as what we did earlier, sort of check the slope at a bunch of points and then check the bounds as well. So G, it's a minimum. We got first gotta check the local maximum minima. So we want G prime of x is equal to 0, which is the same thing as saying f of x is equal to 0. Find f of x is equal to 0 at points 0, -6, 0, 6, and that's it. -6, 0, and 6. So we want to check x is equal to -6. These are the x values. This is the g of x values. We want to check -6. We want to check 0. We want to check 6. So we want to check whenever it equals 0. There, there, there. And we also want to check the both bounds. So -6 and 12 are our bounds. We also need to check 12. And then we can just plug in values, really, right? So what g of -6. So this is going to be the same thing as the g of x is equal to the integral from 6 to -6 of f of t dt. So we need to find negative integral from -6 to 6 of f of t dt, which is going to equal negative sign the integral from -6 to 0, -6 to 0, which is a negative area, negative half circle of radius 3. It's going to be negative pi 3 squared over 2. And then we're going to add the positive area of this semicircle of radius 3, right? So that's going to be plus pi 3 squared over 2. We're going to cancel out. It's just going to equal 0. So this one's going to be 0. Found this one earlier. We plugged in 0. We got negative 9 pi over 2. Plugged in 6. If we plug in 6, we get, hold on a sec, actually. Wait, hold on. This is 0, because, no, it's not. This is when we plugged in g of 0 here, which is negative 9 pi over 2. When it's 6, this function is just the integral from 0 to 6 to 6. There's an identity there, so it's 0. Finally, 12 is what we found earlier, which is 9. So the absolute minimum is at x equals 0. Cool. Next question. Oh, we get a differential equation. I love differential equations. Okay. So we get some cool equation. We get some real solution to our equation. Initial condition. Find f double prime. This is going to be the same thing as finding the derivative of dy dx. So find derivative dy dx, f double prime of x is going to equal to d dx, or is it going to equal d2y dx squared is equal to d dx of 3 minus x y squared. Product rule this, so we take the left derivative, which is -1 or negative y squared plus, negative y squared. We didn't take the derivative of y, we took the derivative of x, which is fine. Plus, and then derivative of the right side times the left, so it's going to be 2y times 3 minus x, and then derivative of y is dy dx. That we could plug in values. We find f double prime of 1. It's going to be plug in values. So we know x is equal to 1. We also know that y at 1 is equal to -1. So we have -1 squared plus 2, -1 times 3 minus 1. We also want dy dx at x equals 1, y equals -1, so we can evaluate that. Dy dx is equal to 3 minus 1 times -1 squared is equal to 2 times 1, or 2. So this is times 2. We plug all these values in. We end up with -1 plus, this is -2 times 2 times 2, or -4, -8. So it's going to equal -9. Cool. Next question. Write the second degree Taylor polynomial for f about x equals 1. God, this is one thing I should know as an engineer. Um, this is Taylor polynomials look like, let me just try to write the form down. It's like Taylor of some degree n of x is going to equal f of, sorry, of x is going to equal f at some value a plus next spot is going to be f of f prime of a over 1 factorial times x minus a plus f double prime of a over 2 factorial x minus a squared plus f triple prime of a divided by 3 factorial x minus a cubed. So we want the second degree, so we don't care about this term. Just plug in our values. We have f of 1, which is negative 1. So negative 1 plus f prime of 1, which we said was f prime at x equals 1, which was 2. So plus 2 over 1 factorial, which is 2, x minus 1, plus what f double prime at 1, which we valued was minus 9. So minus 9 over 2 times x minus 1 squared. So the questions kind of led us into getting this polynomial, right? It like showed us how to get there by making us do the workout. Next question. Oh, fuck. God, kill me. This is bad. This is a bad question. I don't remember at all what the Lagrange error bound is. Uh, let's see. What does this mean? So f triple prime is less than or equal to 60, right? It's like if we took f of 1.1 minus our Taylor approximation at 1.1, that's going to be less than or equal to 0.01. The difference between these two approximations is in our last term, f triple prime, right? So this has to imply that, so if we consider, we want to show this, right? We know this minus this is our error bound, right? The absolute value of this minus this is our error bound. Okay. Ours is going to be below or over it. Okay. F 1.1 has a bunch of terms we don't know, but we know that this is going to be the same thing as if we imagine taking out the first couple terms, or hold on a sec. Um, let's see. Fuck. What is the Lagrange error bound? I just don't remember. Let's see. I think let's think of this last term, right? If we had another term, what would it look like? It would look like f triple prime of a over 3 factorial x minus 1 cubed. It would look like this, right? So this is our last term. We want to show that this is less than or equal to 0.01, or the absolute value of this is less than that, right? For 1.1. So we can plug in 1.1. We get f triple prime of x. Well, we don't really know about how to deal with this term of that times 0.1 to the 3 over 3 factorial, which is 6. So right now this is equal to this. We know that this is less than or equal to 60. So we also know that the real one is less than or equal to 60. So we know that this statement is less than or equal to 60 times 0.1 to the third over 6. And then we know that this is equal to 60 over 6, which is 10. 10 times 0.1. I think this is pretty close to what the answer is supposed to be. Cubed. 10 times the 0.1 is going to cancel out one of them. This is going to be equal to 0.1 squared, which is then equal to 0.01. Nice. So we have shown the absolute value of f triple prime of 1 times 1.1 minus 1 cubed over 6 is less than or equal to 0.01. I think that actually I'm pretty sure this is really close to the Lagrange error bound. I think I did a pretty good job on that question. I don't actually just do not remember. There's like a formula for it and stuff. Using Euler's method, show that x starting from x equals 1 to approximate x equals 1/4 using two steps of equal size. Okay. So we want to use dy dx to find that number. So we can also imagine, so we start at x equals 1. So we have f of 1, which is equal to what? -1. So we're going to go x equals 1.2, and reduce x equals 1.4, and we're going to find dy dx at 1. So dy dx at x equals 1, we said was, x equals 1 and -1, we said was 2. We said this was 2. So with a step of that, we're going to end up with -1, or sorry, we're going to end up with -1 plus 2 times 0.2, which is the same thing as -1 plus 0.4, which is f of 1.2 equals -0.6 dy dx, which is going to be so annoying to calculate right now. Dy dx was 3 minus x times y squared. Plug in our values, we get 3 minus 1.2 times -0.6 squared. Same thing as 1.8 times 0.36. Yes. So we get 1.8 times 0.36, 48, 10, 24, 5, 8, 4, 6. We have 3 decimal places, 0.648. 0.648, 0.648 times 0.2, 16, 9, 12, nothing. It's going to be 4 decimal places, so it's going to be 0.0296. So we're going to add that to 0.06. So we get 0.6 minus 0.0296. This becomes 5. This becomes 9. This becomes 9. This becomes 10. 407. 0.5704. Negative. This seems like a terrible answer. I bet that's wrong. I don't care. Final question. Using the ratio test and whatnot. We get a fucking awesome series. I love series. Question 6. Using the ratio test. Use the ratio test. Okay. Okay. Do I remember what the ratio test is? The ratio test is when we take the uh take the limit as n approaches infinity of the series, right? So x minus 4 to the n plus 1 over n plus 1 times 3 to the n. That times the n plus 1, right? Or it's going to be like a of n plus 1 over a of n, right? Like this. And if that is some value, it gives us some ruling equal to a of n plus 1, which is x minus 4 to the n plus 2 divided by n plus 2 times 3 to the n plus 2 times, and then the reciprocal of the other one, which is n plus 1, 3 to the n. Wait, sorry, this should be n plus 1. Divided by x minus 4 to the n plus 1. Then, simplifying this, we start with the x minus 4, so we're just going to end up with a single x minus 4. Single x minus 4, the n's go away, because those are polynomials. 3 to the n and that go away to become just 1, 3. This is going to be less than or equal to 1. So we get x minus 4 is less than or equal to 3, which is less than or equal to -3. Or x is between, add 4 to both sides, 1 and 7. Cool. Find the interval convergence. That's the interval convergence. Cool. Find the first 3 non-zero terms of the Taylor series. Find the first 3 non-zero terms of the Taylor series for f, the derivative of f. The first three non-zero terms and the general term of the Taylor series for f prime, huh? Okay. So we have f of x is equal to x minus 4 squared over 6 plus x minus 4 third over 3 times 3 squared, which is, I'm just going to keep it like this, 2 times 3, 3 times 3 squared, plus x minus 4 to the fourth, 4 times 3 to the 3, plus dot 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 plus x minus 4 to the n plus 1 over n plus 1 to the n. Let's find the derivative of this, which is going to say, oh, it says to find the first three non-zero terms and the general term about x equals 4. It doesn't mean to plug in x equals 4. So we find f prime of x, which is going to be to take derivative of each terms. So drop down this 2. There's nothing else. There's no chain rule here. So it's going to equal 2 times x minus 4, or just x minus 4 over 3 plus, take down that 3, x minus 4 squared over 3 squared plus, and then drag down this 4, get x minus 4 cubed over 3 cubed. Then the general term, which is drag down an n plus 1, x minus 4 to the n over 3 to the n. Not that bad, actually. So that's the derivative there. Next question. Next question is going to be this next one, which says that the Taylor series described in part B is a geometric series. That makes sense. It looks like a geometric series. For all x in the interval of f prime of x, show that f prime of x is equal to x minus 4 over 7 minus x. Huh. Okay. Geometric series, well, if you add up an infinite number of terms of geometric series, so like some geometric series of the form n equals 1 to infinity, or so let's just say like n greater than equal to 1. It's going to be a of 0 times r to the n. And it's just going to be adding up some term, some term, some term, some term, some term. Problem is when this converges, this equals the value of a of 0, the first term, I guess a of 1 over 1 minus r, right? Yeah, I think so. So, or I don't remember the specific notation. I think it would be 0 here or something like that. Or then this would be a of 0, whatever. The first term divided by 1 minus the rate. In this case, it's going something like this. It's going to be a0, which is just going to be the first term, which is x minus 4 over 3. Yeah, x minus 4 over 3 divided by 1 minus the rate, which is 1 over 3. Where does this minus x come from is the question, though. Oh, I see it. So the rate is not actually 1 minus x, it's actually x minus 4 over 3, like this. Ah, okay. Right, because it's just multiplying by that every time. So this is then going to become 3 at the top, 3 at the bottom. We end up with x minus 4 over 3 minus x minus 4. I think it actually might be r minus 1. Let's try r minus 1 instead. R minus 1, which is x minus 4 over 3. Nope, I just distributed the minus sign wrong. It is 1 minus 4. 1 minus x minus 4 over 3, which then equals 3 minus x plus 4, which then equals x minus 4 over 7 minus x. So, geometric series, use geometric series identity. Cool. Fun. Next question. That's actually a pretty good question. I like that one a lot. Question C. Oh, that was question C. Well, we're almost done. Part D. It is known that the radius convergence is this for the Taylor series about f equals x. I did not read it all. Radius convergence for the Taylor series for f about x equals 4 is the same as radius convergence for the Taylor series for f prime about x equals 4. Does the Taylor series in f prime described in part B converge to f prime at equals x equals 8? Give a reason for your answer. Hmm. Sure. Interval of convergence is between 1 and 7. So it'll converge to f of x between 1 and converge to f prime of x between 1 and 7. So does this converge at x equals 8 is the question. That'd be 4 over -1 should be -4. Hmm. No. No, because it's outside the interval of convergence. No, because x equals 8 is outside our interval of convergence. I don't know what this question's asking. Okay, so now I'm going to pull up the answers and I'm just going to like see if I how much I got right, how much I got wrong, and if I would have passed or not. Okay, pulling it up here. Scoring guidelines. Let's see. Okay, thanks, Adblock. Okay, question one. Uh, did we set it up right? And we got our answer, which is 2.778 acres. Cool. That is 3 points. Next question. Uh, part B. T is 2.154. Uses average rate of change to get 1.282. 2.154. Cool. Uses average change. Answer with supporting work. That is point 0.3 and point 0.4. Wait, hold on a sec. Wait, no, I'm stupid. This is point 1, point 2. That's 2 points. This is 2 points also. So this is 2 points. This is 2 points. Next question. Part C. Write the limit. Value equals 0. Limit expression. Value equals 0. Okay, it's 0.5, 0.6. That's 2 points. Next section. Time here. I want you to test A of 4, A of 11.44, A of 36. Considers A prime equal to 0. Answer is 11.44. T equals 11.4417. T equals 11 point. I made a typo here. I meant to write 4417. I would say that's probably 3 points here. I think a typo would probably be fine. They probably don't care too much about that. So that first question was 9 points. That is a full score. Check, check, full score. Next question. Oh, I probably should stop the timer, huh? I'm done. Pause. That's the time. Here's some curve. Answer should be 1.03. That's 1 point. 1 point. Uh, here. Exact answer earns 1 point. Okay, cool, whatever. Part B. Find the area. Oh, I wanted you to calculate the area. Let's see. Did I do it right though? It's 1/2 from theta 1 to theta 2. 2.618, 0.5235. Okay, so I didn't do the calculation, but I did set it up right. I'm just gonna say that's all 3 points. I even plugged in the calculator. It's like whatever. But I did plug everything in properly. Next question. Interesting. Okay. Next question. It can be shown this considers the x equals 0. Yep. Justification. I didn't do justification. I just kind of wrote it out. Were you supposed to check the endpoint of the interval? I feel like If I did I think when I was describing it, I sort of mentioned my justification would include the look at the to fucking look at the thing and see that at the initial bounds it's not far away at all. So I think that's a fairly reasonable answer for this one. I'd say it's a three. Next question, just 15 times that, right? Yeah, 15 times the answer from earlier. So that's 2 points. That is. No, wait. Are we eating dinner right now? Soon. What sort do you want? I'll get you one for dinner, okay? 2, 5, 8, 1. Okay, so that's 9. I guess I'll take a point off because I did not write the answer out for this question, so that's 2, or that's a 8 out of 9. Next question, part 3. Let's see. 5 words per minute. That's 2 points. Uh, is it intermediate value problem? Let's find out. Differentiable implies continuous. Answer with justification. Intermediate value theorem. You don't need to actually include intermediate value theorem, I don't think. Let's see. Does not need to explain the intermediate value theorem, but if you name a theorem, it must be correct. So I didn't name a theorem, but I also didn't say the wrong one. So that's 2 points, I think. 2 points. Trapezoidal sum. Let's see, 1252. That's good. Or is that 3 or 2 points? I don't wasn't paying attention. 2 points. 2 points. Um, read equals. Oh, they read equals as a semi-equals, so they didn't actually care if you didn't write semi-equals or equals or whatever. Next one, 1300. That's 3 points. Cool. Next one, let's see. Considers that, says 1. 2 points. Um, Next section. Points of inflection because f changes from. I did say that it needs to change from increasing to decreasing, but basically that whatever. Oh, I figured the wrong answer now. G has points of inflection at x equals -3 and x equals 6. Would it not be also as a point of inflection at x equals -3? So I actually got the wrong answer because I forgot to include x equals where's the graph for this question? I forgot to include x equals 6, which I guess makes sense because the slope goes from decreasing to increasing. I guess I don't really consider that. I don't really consider when it equals 0, but I guess some freaky stuff also should be included. So I think this is only going to be 1 point for this question. Let's see really quick. Why we scrolled very far down there. Responsive. Wait, let me see. A P3 is only earned for all three. Turn P4 a response of the 2 of the 3 correct answers with correct reasoning and no other points earns P4 but not P3. Yeah. So it has 2 of the 3 correct x values with correct reasoning. So that's fine. That's 1 point. G of 12 is 9, -9 over 2. 9 pi over 2. Yep, so that's 2 points there. Next section. Uh, G prime of x. Yeah, x equals z. Let's see. Minimum value x equals 0. I did the candidate table. We did g prime of x equals 0, f of x equals 0. That's 3 points there. So this also was 8 out of 9. So that's 8 out of 9. This one was 9 out of 9. That was 8 out of 9. Next question. This one. This one I'm worried about a little. I don't know if I did it right or not. But let's see here. D2y chain rule -9. That's 3 points. Next question. Taylor polynomial. Let's see. Should be -1 plus 2x minus 1 minus 9 over 2x minus 1 squared. That's 2 points. Now the Lagrange error bound. This is the one that's tricky. We got f of that minus p2, which is equal to the max of f triple prime over 3 factorial. So I wrote, instead of writing that, I wrote f of triple prime of 1, which is technically wrong. It should be the max along that interval over 3 factorial times x minus 1 to the cubed is less than or equal to 60 times that. I would say, I think that counts because I show that this term is less than or equal to 0.01. So I think that's 2 points. but I should have remembered that it's the max of the derivative along the point. This one is negative 0.47. Did I do my math wrong? Is what I want to know here. So it was, hmm, negative zero point 0.6. We did get the negative zero point 0.6. Then we got dy dx. So it was negative zero point 0.6 plus 0.2 times this. Wait, I want to see. Did I just add wrong actually? Hold on a sec. Zero point 0.2, hold on. Zero point 0.2 times 3, or times 3 minus 1.2 times negative zero point 0.6 squared. Oh, that's 0.1296. Wait, did I just write 0.9? Wait, my slope is just wrong. It should be 0.1296, not what I got. Wait, 1.8 times 0.36. 0.648. Oh, I fucked it up. Wait, what? I'm so confused. Wait, zero point 0.6 squared. 0.36. Wait, 3 minus 1.2 is 1.8. Did I forget to multiply by the zero point 0.6 squared is 0.648. 0.648 times zero point 0.2 is, okay, I messed it up here. I forgot to carry this one down. It should be 0.10296. So I'm off by 0.01. Let's see. First step was right. Answer was going to work. I think that's only 1 point there. So that would be another 8 out of 9. Yeah, 3, 2, 2. That's 7, 8. Yeah, 8 out of 9. So we've lost 3 points so far. Moving on to the final question, which I think I definitely lost a point on this last bit here at least. Let's see. Ratio 1 between 1 and 7. Oh my gosh, I forgot the endpoints. Fuck. That's only 3 points. I lost 2 points there. When you do this, you're supposed to consider the endpoints. Shit. It's been so long since I've thought about this. Yeah, okay. Next question. Did I get the right terms? Yeah, I got the right terms. That's 2 points. Geometric ratio did the workout. X minus 4 over 7 minus x. That's also good. That's going to be how many points is that? 2? 2 points. 2 points. Wait, that was the previous question. This one is 2 points. This one's just 1 point. And then the final question, radius convergence would be outside the radius convergence if it was not converged. So that's going to be 1 point. That was 1, 2, 3, 4, 5, 6, 7, 8. So that's, well, no, 5, not 7. 7 out of 9 because I lost 2 points in this question by not considering the two endpoints. So in total and all, we got 7 out of 9. I'm just going to add it up. 7 plus 8 plus 8 plus, this one was good, 9 plus this one's 8, I think, plus 9. And that's out of 6 times 9. So we got a 90.7% on this exam. I don't know what that means really, but that's what I got. Anyway, thanks for watching. Um, bye-bye.